it is.
Is it recording? Now I can see. Okay.
I think so. Everybody, best behavior. If anyone acts up, it's caught on tape. And it will be put on your permanent record. Okay, fantastic. Hello, everyone. So I am Mr. Thorne. I'm Priya's papa. And every day at the start of the year, I always look at your science syllabus because I want to know what Priya and everybody else is studying in science. As you know, some of you know, I'm an electrical engineer. I build circuits and all that, but I am fascinated with everything sciencey. Anything that sort of helps me measure the world around us. That's sort of my way of getting closer to the universe and being one with the world. So you guys are studying weather in your classes, and I know you're talking a little bit about rainfall and things like that. And I saw in one of Priya's homework sheets, you're talking about thermometers and barometers. What other weather instruments are you talking about? Anemometers.
Rain gauges.
A rain gauge. Okay, gauge, however you say that. Yes, sir.
Hygrometer.
A hygrometer. And what's a hygrometer do? Oh, wow. So after today, I don't think you'll ever forget it. Yes? Barometer. So we're going to talk about most of those things today. That's fantastic. And so the weatherman, does his weather report and all that. And, ancient man, and I wrote this in my book, ancient man, they didn't really have to know how many degrees outside it was, right? If it was cold, they just put on another woolly mammoth skin, right? Or they went into their cave and started a fire. But it's very important for us to know how to measure weather because, if a plane's taking off, it wants to know, well, gee, there's no ice on the ground here, but what about when I get up into the air? What if I get ice on my wings? There's all kinds of important things here. And Miss Rouse fanning herself like it's really hot and humid in here. So, that's another reason, right? So you don't want your house to burn too much energy. So you don't want your house to burn too much energy. So you want to build just the right size furnace and all that. So very important reasons to want to measure weather. So a thermometer, let's start with that. And I'm going to draw a little picture here. Did you go over how a regular old thermometer works? Mm-hmm. Okay, how does it work?
You put it outside and it tells you how many degrees it is.
But how does it do that? Yes.
You get like this red liquid off the rock or something.
Yeah.
And you put it in there. And then
That's
it,
right.
like,
And one more.
Sometimes
Mercury, that's right. And what do we know about Mercury?
it's It's the hottest planet.
to the sun.
It's
Well, no, I mean Mercury, the metal. The
Oh.
other Mercury.
It's
Priya?
liquid.
It's liquid. What else about it?
It's red.
Yes.
Poisonous?
It's poisonous, so we don't want to use an awful lot of it, right? So most thermometers have a red liquid. And the way that works,
The blue and the black ones work best, I think.
blue and black, here we go. So let's go with this. So the way that works is you have a little ball, a little glass thing like this, and it's hollow. So in here you have some alcohol and a little tube that goes down like this. And so the alcohol is filled all in here. And what do you know about things that get larger? Or, I'm sorry, what do you know about things when they get hotter? What happens to them?
They get larger.
They get larger, right. So the alcohol gets larger and squeezes down this tube. But the glass gets larger too, but not as fast. So the alcohol wins and it gets hotter and the alcohol comes up. But how do I get that number into a computer? So if a weatherman, do they have to send a human being outside to look at the thermometer each time? Well, no. So we can also measure temperature electronically. And this is one of my thermometers. So let's turn it on here, and it says 76.1 degrees in here. And the way this thermometer works is this little metal thing has a little skinny platinum wire in it. So what do you know about platinum? What do you make out of platinum? Yes.
It's like a type of metal.
It's a metal, but what do you make out of it? Yes? A battery? Not really. Yes?
Maybe it works for wires.
It does work for wires, but the thing that people like it for is jewelry. Okay, so it's very shiny and it's very expensive and it doesn't react. And when it gets hot, it's harder for electricity to flow through it. So this little box measures how hard it is for the electricity to flow through a little piece of platinum wire. So I'm going to start this here. So you can pass this around, and it's sort of sharp here. It's not super sharp, but please don't do this. That's no good. But just put your hand around it, and you'll notice the numbers go up, and take your hand off, and you'll see the numbers go down. So just take it for a few seconds and pass it along. Okay, so that's one thermometer. And then I have a couple others here. So what about on the outside of an airplane? So an airplane needs to know the temperature, and that's pretty fragile to put on an airplane, and you wouldn't want to put a little fragile wire there. So here's a couple more thermometers, and these things are, I want to say bulletproof. Can I say that here? They are very, very indestructible. Okay, so I'm going to pass these guys around too. So these are the kind of thermometers that you would use if you put it in a really harsh environment, like really, really bad weather in the bottom of Death Valley or on the top of a really snowy mountain. So I'm going to pass these guys around too. So that is temperature. And there's a lot of other ways to measure it, but those are the ones that I'll illustrate today. So the next thing I heard someone mention was a barometer. So what's a barometer do? What's that measure?
Measure
You.
air pressure?
Air pressure, right. So it's how much the air is squeezing you. Can you feel the atmosphere squeezing you right now? No? All right. Okay, well, let's see. I've got some explanation here, but let me check my notes here. I'm going to pass around a barometer, too. Okay. So don't ask me where I get all this stuff. A lot of it comes from eBay. I never pay too much for it. This is my favorite barometer, okay? And it's very nice, and it's probably very expensive, and I like it a lot, but it's in a pretty rugged enclosure. It's meant to be kind of handled around, but I would ask that, try not to drop it. So if you read on here, you'll see that the needle is it's reading about 1015. So 1015 millibars is the measure of pressure in this room. And if it gets rainy out, this needle will move one way. And if it gets really nice out, the needle will move the other way to higher pressure. And if you look inside, you can see the little gears and mechanisms going on in there. So this is my favorite barometer that I pass around. Thank you. Like I say, it's pretty rugged. Try not to drop it. Okay, so air pressure, aha, now we get to some good stuff. So if the air is squeezing us so much, then why doesn't this soda bottle collapse? Why is it not squeezed? No? Yeah, why? Well, it's made out of plastic, but I can squeeze it pretty easily. Priya? Well, yes, exactly. There's a hole at the top. So the atmosphere is squeezing from the outside, but guess what? It's squeezing from the inside as well because it has a hole in the top. And the air can flow in, and it stays the same shape. Now, who remembers what this does from last year? Yes?
It sucks in all the air.
Yes. Okay, so this little guy here pulls all the air out of whatever you connect to this tube. Aha. So, I took the cap of a soda bottle and I drilled a hole in it and I put a little brass fitting on it. So now this gives us the ability to pull all the air out of this poor bottle. All right.
Can you do this at home?
Okay, so that all works.
Can you do this at home too?
All right. So, you've squashed bottles with your hands before. You think you could do that with your hands? Not really.
Like that.
There's no air left in here. It does not get any smaller than that. Ayush, can you hand me another bottle, please? Here, pass that around.
This is the biggest, hugest ball that will be never able to breathe.
I'll never be able to squeeze it? Well, I certainly won't, but our atmosphere is squeezing us with 14 pounds per square inch of pressure. So in this much area, the atmosphere is pushing down with 14 pounds.
I was in a crack.
Ayush, can you hand me one more, please?
I was in a crack though.
Well, it's getting crushed. The atmosphere is incredibly strong, pushing on you.
It's wetting you from all the water.
Well, I didn't want it to have soda in it. We wanted to clean it out. Okay. And last one.
Oh, no. The waters are expanding. Why?
That's amazing.
Scientists.
All right. And we can pass that guy around too.
All
All right.
right.
So do you think I could I use a bottle like that to tell what the weather's going to be? Yeah, probably not. That just shows you how powerful. Yeah, Sechi, you can open that. Okay, great, thank you. Thank you very much. Alrighty, aha. So,
Oh, that's heavy.
in your science class, have you learned the difference between a qualitative measurement and a quantitative measurement?
Not yet.
No, okay. So qualitative is, man, that atmosphere squishes a lot. Okay, it's yeah, you can say it's a lot, but there's no number on it. So let's just start, well, and in contrast, that thing I'm passing around is a quantitative number. I can tell on there exactly how much pressure the atmosphere is squeezing down with. But I can't get that into a computer. So here's my next little toy. And this is from a weather balloon. And when scientists want to know the properties of the atmosphere, they want to know how cold the atmosphere gets as you go up in height. They'll take a weather balloon and they'll put a little box with some circuits in it and one of these to measure pressure. So what I did, I don't know, can everyone see this? There's a little lever here.
Yeah.
Can y'all see that lever that moves? Yes, Corey.
It's like a mousetrap.
It does look like a mousetrap, but it's a barometer.
Oh, like the game mousetrap that we have.
Okay, so what this guy does, there's a little metal can in here, and this metal can has a vacuum in it, just like that bottle. But this can's made out of steel, so what that means is it can resist the atmosphere pushing down a little bit. So if we take away the atmosphere from the outside, this can gets bigger, and this little guy goes down. Now, how do we know that that little guy's going down? I rigged up a laser beam to it because everything's cooler with lasers. Oops, there we go.
Look at it.
Okay, so you see the laser light there? So what that means is now, if this lever moves, it moves the light. Okay, so let's try this out. So we're going to put this inside the vacuum jar. And I wrote in my paper, and I'm going to be very careful not to shoot anybody with this. Okay, so I wrote in my paper that if we just sit here all afternoon and wait for the weather to change, maybe we'll see that dot move a little bit, and that's really boring. So we're going to simulate a massive storm front coming in and dropping the pressure in a big hurry. So with that, we'll take this vacuum jar. Okay. So there's that. We can still see the light, right?
Yeah.
Can everyone can see the light?
Yeah.
No?
It looks kind of fuzzy.
Yeah, it's a little fuzzy, but you can still see it, right?
Yeah.
And this little seal needs to go right down on here. Aha. Okay, so there's that. So I've still got that, and now let's start pulling the air out. Okay, everybody, let's check the weather. We have a massive storm front coming in, and I'm not going to touch this. It's going to do it all on its own.
Whoa.
Okay, so now that weather balloon can tell exactly how high up in the atmosphere we're going. So as the weather balloon goes up, 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 the little lever goes doink, 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 and you can measure it back on the ground. So let's let this go for a little while. And it's just from dropping the pressure. So now I can measure atmospheric pressure. Yes?
But the thing that makes
It's not going to go all the way around the classroom. It is limited to about a 45-degree swing.
Is it moving, and how is it not moving?
How's it moving? Well, I dropped the pressure. The vacuum chamber's expanding, pushing the lever, and it's moving. Okay, so everyone's seeing it moving this way. So let's cut the vacuum. And I'm not going to rotate this at all. There we go. So that's what happens when the weather balloon pops and the thing falls back to Earth and the little scraper goes back the other way. Okay, neato. So I think we are done with the vacuum jar. Oh man, I want to see more vacuum experiments. All right. So yeah, so this was kind of a fun project to make. Had to go around to Michael's and buy some little wood ovals, and to my favorite electronic junk stores for laser pointers. Yes, Priya. You saw what? Oh, yeah. Tell you what, next time that's your job, okay? You have to wear gloves to do that, though. All right. So what are we going to do next? Let me check my little syllabus here. So we've got pressure. We did temperature. Pardon me. And back to measuring pressure, barometer. I think we're up to wind speed. And how do you measure wind speed again? What was the thing that you used to measure wind speed? Anemometer. What's that?
Anemometer.
Yeah, it's an anemometer. Okay, so we've got one of those here too. So an anemometer. Has anyone seen an anemometer?
Yes.
Okay. Yeah, what's it look like?
I don't remember because I just saw it for a few minutes.
With what?
I saw it for a few minutes when I was really
Ah, okay, and yes.
And it's kind of like a stick. It's a cylinder, and
Okay.
on the top there's there are 4 cups.
Yeah. Right. So like a 3-cup or a 4-cup anemometer. That's exactly right. It's like a little propeller. And I have a picture of a weather station in the book here. But this is my anemometer. And this is designed for measuring the airflow in mine shafts. Okay, so if you're in the bottom of a mine, like mining coal or something, you want to make sure there's enough airflow coming through, and you might use something like this. And it's very sensitive. So let's see if I'm just going to blow gently.
Whoa.
Okay, and you see the vanes moving. So this can be used to measure very, very slow air speeds, and it has a dial in it that tells you how many feet of air have passed.
The air
Yes.
over there is a measure.
Sorry, what's that?
The air over there make it measure.
Yeah, you're probably right. It is sensitive enough for that. And you asked the question, what if it went too fast? Okay, well the first thing that'll happen is it won't be very accurate. So every instrument has a certain range it'll measure in. If it goes, maybe it'll measure 20 miles an hour accurately, but maybe if you put it up on your car and drove 60 miles an hour and then you looked at the reading, you might read 70 miles an hour. So you see what I'm saying? So if it goes faster, it's not as good at measuring. And yes, Priya?
If it's gone fast, would it break?
It would. So the ultimate limit of this thing is the bearings will give out or the blades will fly off, and that's no good. Okay, so for this, Priya, would you be my assistant for this next experiment? So the way this thing works is we need a stopwatch, and it has a little lever up top that either starts or stops the needle. So the needle's stopped, and we're going to make a measurement, and we're going to measure air flowing for 1 minute here. So we'll try not to take too much longer than that. Make sure we're going the right way. Okay, so here is, so air needs to blow this way. So I'm going to set this here. So Priya, can you come up here for a minute? And that is why I brought along a timer.
Oh yeah?
So let's generate some wind with the little fan. There's that. Ooh, much better. Okay, so this thing, we're moving this guy here. And you know what, I'm going to pass this around after so you can get a close look at it. But the needle's not moving. But Priya, see this? If I move the lever and get it going, then yeah, we're moving in the right direction. So Priya, I need you to come move this lever back and forth. So come over here, please. Okay, so let's do a practice round. So hold it like this, and then flip the lever this way, that way. And yes, we're moving. So let's flip it back and reset the needle. Yeah, and then we need a minute. So let's get a high. Yes, bud.
I won't pull that thing.
Okay, we'll do that later at home. Okay, bud. All right. So this is my most favoriteest timer, and everyone can hear that. All right. So let's time for 1 minute. Okay, Priya, I'm going to go 3, 2, 1. Is the blade spinning? Okay, you ready? So 3, 2, 1, go. Okay, so take your hands away from it, and we're just going to let it spin. Okay, so this is a pretty concrete example. Everybody knows that a fan blows, and everybody knows that I can measure feet. But what is airspeed measured in? What speed measured in? Is it measured in feet? No? Is it measured, yes? Meters, just plain old meters? The wind is blowing 10 meters. 10 meters what? Yes. Miles what?
Miles per hour?
Miles per hour, exactly. So miles per hour. So you need distance divided by time is velocity. And we're almost here. So here we measured feet, and we're measuring for 1 minute. So this measures feet per minute. And one second. Hold that thought. You get ready with the lever to push it the other way, Priya. So hold the top. When you hear the sound. All right. Cool. Okay. So if I look at the dial here, and I'm going to leave it set. This dial says 100, 200, 295. Oops, that's the bad one. That's the bad one. Where's the good one?
It's on the ground. It's on the ground.
Or black.
Oh, did it fall?
Yeah, it's on the ground.
Oh, here it is. Okay, thank you. So what did I say? 295. 95 feet per minute. Okay, and then I went to Google and I Googled feet per minute, no, miles per hour in feet per minute. Could somebody multiply this 295 times this number, 0.01136 equals, that'll tell us how many miles per hour. So you guys probably don't have calculators.
I have a
You have one on
calculator.
there.
On my desk.
Okay, so let's call out the number when we're done. And what was your question?
I saw the needle go around, like one around the whole circle.
Yeah, exactly. So if you look at the smaller needle, the little smaller needle tells you how many times the bigger one went around. And with that, please be careful of this and don't touch the vanes, okay? There. Everybody got that? I'm going to pass this around. Please don't touch the vanes. Just hold it from the outside.
Can we blow it?
Yes. Go right ahead. Okay. Gently. Please don't get spit on it or anything. Yes, Priya. Thank you very much. Okay, so we did wind speed. So very careful. Thank you very much. And I think we are just about. Oh, thank you so much. Is that right? 3.35? So that's not very fast. So this was. So 295 feet per minute
That's a lot.
is 3.35 miles per hour. Well, it doesn't sound quite right, but let's go with it. No, that is right. 0.01 times that. That's about right. Okay, so so we were measuring a pretty small, a pretty low wind speed. So that's like walking quickly. And with that, let's see what we have next. Okay, somebody said hygrometer, and what does a hygrometer measure again?
Air
No, that's a barometer. What's a hygrometer?
Water.
Water where? On the ground and above?
Water. Freezing water in the air?
Well, it's water in the air, not necessarily freezing. So,
Precipitation.
what's that? It tells you if precipitation is likely. Yeah, so if it's a very dry day, then the humidity is low. So it measures humidity. Now, who's been to Houston in the summer? Okay, a couple people have been to Houston in the summer. It's really hot and humid, and you don't sweat much. The sweat just stays, or you sweat a lot, but it stays on you and you get drenched. That's because there's a lot of water in the air that's preventing the sweat from coming off of you. So, in order to measure humidity, we can use a device like this. So what we have here, and I am not going to operate this, but I have a picture of it working there. So this is called a sling psychrometer, and I'm not going to pass this around because it is mercury thermometers. The mercury is safely contained in glass, but what you'll see is there's a little sock on the end. So one thermometer is dry, and the other thermometer has a little sock on it that you dip in water. Yes, Priya?
Why does it have a sock?
Well, because the sock is like a little dude or dudette that's sweating like crazy on a hot summer day. And you swing this thing around in the air, and if it's a nice dry day, then your sweat does its job and you get cooler. If it's a really humid day, your sweat doesn't do its job. So if it's a hot day and this guy is the same temperature as this guy, the sweat's not doing its job, it must be a really humid day. But if it's nice and dry, the dry thermometer measures the temperature, and the wet thermometer is a lot cooler because your sweat's doing its job. And so that's how you measure how much water is in the air. And once again, if you're interested, this is in the little book there. This has a swinging handle on it, so you swing it around to make some wind. And that is the psychrometer to measure humidity. And we have one last experiment because, once again, it's hard for a machine to do that. It's hard for a machine to look at a thermometer and measure the temperature. So we always are looking for something that a machine can do. And with that, let's do our last experiment. So what do you call the water that you see on the grass first thing in the morning?
Dew.
Dew, okay. And have you ever heard the weatherman say what the dew point is? So they'll say the dew point is this or the dew point is that. And let's see if I can remember this. A high dew point means there's lots of water in the air, and a low dew point, oh, thank you very much. A low dew point means you have to get the air really, really cool before the water starts to condense out of it. So let's see if we can find a way to measure that electrically, because we always like to get our measurements into a computer so that we don't have to go and look at our instruments in person. We want machines to do our work for us. So let's see what we can do here. Bear with me for one small minute. Aha! Does anyone know what this funny thing is? Yes? It's not a bell. Yes? No?
A ring?
No, it's from a computer. Karina? No. This is the heat sink from a CPU and a computer that I garbage picked from work. Someone threw it out and it was perfectly good. And this little guy here is called a thermoelectric cooler. Have you seen those little refrigerators, little baby refrigerators that you can put in your car or something?
Yeah.
Well, I ripped one apart. Oh, I mean, I gently disassembled one. And I got out this little thing here. And if I put power into it, one side gets hot, the back side, but the top side gets cold. How cool is that? Well, it's cold. Okay, so let's rig up our experiment here. So remember, if you go out on a cool day and you breathe, you see the, how does this thing work? You see your breath in the air because you increase the moisture and you pass the dew point, so your breath condenses. So let's see if we can do that electrically here. Okay, so there's that, and I need, let's take a little mirror. What happens if you breathe on a mirror? It fogs up, that gets dew, right? Okay. Hey,
Mirror, when I go on it, on my closet, it does that.
yeah.
And then I kiss it.
Okay, Ayush, where do we get these mirrors from? Where do we get this mirror? Do you remember?
When the glass always broke apart.
That's right, we got it from an overhead projector from a computer that somebody was throwing away. So once again, good stuff comes in boxes like that. And then, let's see, so the next thing we need, this is a green laser pointer. And let's see,
Where's the red one?
where's the red one? Well, green is so much easier to see. So what I'm gonna do is lay this mirror down. Let's get that just right. There we go. Okay, so you can see the dot there, right? And then I'm gonna tape it down, but before I do that, so this is a power supply. This is a box that I can use to control the power into that cooler.
My face.
All right, so let's wire this guy up. And I'm gonna take this off so I can make sure that it's getting cold instead of hot. So negative, positive, and in an ideal world, I would have everybody come up and touch this thing. But you can, I think everyone kind of knows that when something is cold, it gets moisture forming on it. So I'm going to prove to you electronically. There we go, so that's getting cold. Okay? So, without touching it, how are you going to believe that it's cold? And here is how. Let's take this button down. All right. Could someone darken the shades over there? Because it's really Yeah, okay, or just dim the lights, that would be, or turn the lights off. Okay, yeah, just turn them off. There we go, okay, so let's see if this works. So, let's see what happens here. So, in a minute, that's gonna start getting cold, and I may help it along a little bit. Okay, can you see around the dot there, what's happening? Is it getting Yeah. You know what, let's, I'm trying to think, let's see.
I see a
You see the little halo around it, right?
yeah,
I see really tiny green
Oh, there we
dots.
go. So you see the green dots all around it?
Yeah.
No.
Yes. Yes.
Okay, thank you.
I see it. I see it.
All right, so we got some that see it, some that don't. I'm gonna fire from the other direction here. So let's see if we can get a little better over here. Yeah, okay, that's a little better, right? You see the halo around it?
I can see it. I can see it.
Okay, so I'm gonna point it at the mirror where there's no condensation, and it's a nice sharp dot, right? And if I move it to the cold spot, I get that halo.
Because he fogged the.
Okay, so it's cold because I put it on top of that little thermoelectric cooler, that thing that gets cold when I run power to it.
It's getting cold.
So it is, and you can tell that because there is condensation on it. Okay, so if I take this thing, if I'm a maker of weather instruments and I want to measure dew point, I can build a little box like this and I can measure the temperature of the mirror, right? We already showed how we could measure temperature electronically. So now all I have to do is build a little circuit to go in there and keep the mirror just where it starts to fog. And I can sense light pretty easily electrically. I can have a little sensor that senses light.
There's a green dot.
Huh?
There's a green dot.
I turned it off. So now I have another device that I can use to measure dew point and get another piece of real information about the weather around us. Okay, could someone hit the lights?
Oh, let's just stay right there. Why is it
Okay. What's that? Oh, okay. So someone asked why the light on the front of my box is changing color. And the reason is I bought this thing broken from a junk store and I fixed it on my lunch breaks. But we have the same one at work. And I wanted people to know that it was mine so they wouldn't steal it. So I put this blinky light on it. So now if I walk around a bench and I see that blinky light, I say, hey buddy, you stole my power supply. Okay, was this interesting?
Yeah.
Okay, got it. I had a lot of fun. I think that studying weather and studying science is a fantastic thing. Good luck on your tests and study hard. And I was happy to hear some of your comments. That means that you are studying barometers and psychrometers and all that, or hygrometers, I should say. And hopefully this helps you remember things for your test. Thank you very much. I'm all done.